Muito obrigado. Unfortunately, I'm not able to speak Portuguese, so I will speak English, which is not also my language, but we'll try to make with that. Thanks a lot, Stefan, for this invitation, this possibility to communicate here about a subject I'm thinking about from many years, and you will understand on many ways. I'm not trying here to give a definition of what is representation or this kind of thing. Philosophers have their own definition. I think that physicists, as I once was, have another definition, and musicologists must, to my opinion, make their own. The fact is that representation is something, to my opinion, important, and what's in the course of music analysis history, you can see that analysis uses representations. So it might be interesting, and specifically nowadays, to have some questions, because I think I will have more questions than answers, about what is representation and what does it mean for us in the practice of or conceptions of music analysis. In fact, representation is a very old thing. Perhaps we can think about the score as the first representation, and representing music is not something easy at all. Perhaps there is a contradiction in between the idea of music and the idea of representation, and that contradiction you can, well, understand it through the work of Schopenhauer if we want to go to philosophy. But I think it's very easy to understand that music is reluctant to be represented, and sometimes that music avoids the idea of representation, or music is the good example of something that is not possible to represent. So there is a paradox, and this paradox, I mean, needs a kind of reflection, specific reflection, and specific epistemological reflection. And that's more or less what I try to do there. So we'll have this talk in three parts and a conclusion. The first part deals about the question, when we speak about representation, do we mean representing the music itself or representing its analysis, which might be something different. And that will be the first question I try to address. The second one is about representational spaces, topology and projection. It means representing, most of the time, means coming to a visual issue. My colleague yesterday said that comics were a very important thing for musicology. I do think so, in the way that if we understand more easily drawings, then we understand words, and then we understand perhaps symbols, mathematical symbols, and things like that. So there is something important, and important also for the pedagogy of music, perhaps. I will not deal with that, but it's a point. And then the third point, but not the easiest, It's representing time, because music is an art of time. Time is always present in the conception of music. And what does it mean, representing time? Because this is also a very big issue. And the conclusion, I tried to draw a general perspective of all what we will see. And I tried, whenever I go to a concept, to give a specific example of it. So let's start with this question: representing the music or representing its analysis. The first musicologist I will quote here is a German musicologist, not very well known, that is called Hans Mersmann. He published a book, Versuch einer Phänomenologie der Musik. It dates back from the beginning of the 19th century, 1922. He was very influenced by the phenomenological approach of its time, and he gives us an example from this. I'm very sorry about that, but you'll have to know that my conference was also a kind of composition with with noise. It's whenever there is a little bit too much white in the screen, you'll hear all those little sounds. So don't worry about it. It's normal. So this is the score is speaking about. Let's hear a little example of the score. So we see only one part of it. I don't know why. That's another problem. Okay. I'm sorry, I have a problem. We see only one part of the screen. Here I have the full screen, but you don't have it. I don't know why. Somebody can help. Everything is there, so okay. Don't ask me why. That's my thing of technology. So we see a score, and then okay, it's the only thing we have from the original music of EITAM, and this is the first score edited from EITAM. It is not a score that will play nowadays a pianist. And in fact, it can change something. So there is already a problem with representation, because this vision for an interpreter, for a performer, can change something. So representation is something that deals with the analysis that makes Mersmann is very very classical. He's using the notion of Vordersatz, und Nachsatz, means antecedent and consequent. The most interesting thing, and why I'm showing this example, is because he gives this diagram of the piece. And it is more or less one of the first time we can see this kind of diagram. This diagram means that there is a Spannung und Entspannung, means tension and relaxation. So he draws an axis with this parameter, tension and relaxation, and try to make a curve to show in this part of the piece there is a tension, and in the other part of the piece there is a relaxation. And of course this scheme is a very, very, very common practice within the music understanding. I remember having a lot of discussions with Michel Lamberti about this idea of tension détente, tension and relaxation, and saying that in fact in music it was something much more complicated than that. But the idea of Mertzmann is very interesting because from his point of view he is drawing the sensation of somebody listening to the music. So it's not does it mean representing music? Does it mean representing the music? What do we call music? Is it the acoustic phenomena, or what gets inside our own brain? So this is a very interesting question. Of course, this kind of representation, you can still have them today, perhaps on less, let's say, a more scientific way. For example, with the work of Geoffroy Peters about descriptor audio, audio descriptors, and it's very interesting. But the list of such descriptors is so long. Then, well, what are we to choose within all these descriptions possible? So we can make curves with music, we can make plenty of curves with music, we can define as many parameters as we want, but what's the purpose of it? And are we doing analysis doing that? So that's one question. Another little thing in Mertzmann showed us this. This is a little bit the same idea, but he thinks, okay, if I can do that for one piece of music, perhaps I can do the same thing with all the history of music, showing what are the more tense moments of this history for each, genre. Don't know how to, you know, you can see instrument music, Ars Nova, and then Monteverdi, Mozart, a little mountain here and a big mountain for Beethoven, and it's very interesting because it gives us the idea somebody in 1920 could have of the history of music. Well, we're not more clever. Huh? This is Google doing exactly the same thing, but with the different jazz, pop, rock, metal, and so on, popular music genre, and according to the references he has in its database. So this is a measurement. It's very different than what Mertzmann was doing, but the representation looks a little bit the same. No? This you can find in Google site. So, okay, we can have parameters and measurements about music. The former ones were sociological measurement, right? So it's measurement. But what do we do with this parameter? How do we understand it? And I will show now another example that I think it is very interesting because it's working on one parameter but tries to understand something through this parameter. This is the work of Jörg Langner. Jörg Langner published it at the end of the 19th century. I think it's 1997. You have all the references there. And the idea of Langner was to study the dynamics of percussion performance. So dynamics is very easy to measure. You can have a curve of the dynamics, okay? And then what? So the idea of Mersmann was to do, of Langner, I mean, was to do a kind of multi-scale interpretation of those measurements. It means taking the most detailed version of it, and then having a kind of temporal mean, temporal aperture of the interpretation of the curves, and then it leads, if you do this on several layers, it leads to this kind of representations. And it's very interesting because, you don't have subjective interaction with this kind of dynagrams. He called that dynagrams. But you can see the subjectivity of the performance. This is the same diagram, well, the same construction, I mean, with two different performances. One from a very good percussionist and one from a student. And it's very easy to see that the performance of the professional is more shaped than that of the student. And here you have another example he gives in a further paper that is even more explicit. So it's very nice because you have only one parameter, but you can deduce from it a kind of representation of the structure of what's happening in the piece. So this is interesting because, of course, it is not a structure in the way we will understand the word structure in some moments. But it appears like a structure. And it gives us the possibility to understand that with only one parameter you can make a structure. And it's dealing with time. So, that was my first point. Let's go to the second point. I will be a little bit broader with the second point, because in fact this second point was a little bit related for me to a question about Brazilian music. I will tell you about that. In fact, this begins with an article on the first number of Musée Médiane. That is a review that you can find freely. It's very open. And we started this because one of the problems that appeared to us very important for musical analysis in the 21st century was the fact that we could have multimedia analysis. So the first example we had, it's a little bit historical, but it's about Hermeto Pascual. And dates back from to 2002, so it's for me a little bit old. It's not the representation I use now, but I hope it will work. We'll see that. So it was at that time very astonishing to be able to see some forms related to the harmony, because it was the first time. And what was the question? The question was that Jean-Pierre Cholton that asked me to work on this Hermeto-Pascual harmonies, was unable to find the logic in it, because of course if you try to understand it just like something is not functioning, it's too complicated. It means that his traditional representation of harmony was not sufficient. He was a very good musician. Of course you always can try to do it, but there is the explanation why it's not so easy, and why, in fact, there is something else happening. There are two kind of chords in Hermeto-Pascual. One kind is this kind. It means that he uses nearly all the scale, all the diatonic scale as a chord, except one note or two. So it's a lot, and it's difficult to find out when you do that what is the bass, what is the bass in the Rameau meaning of bass. So this is one. Sorry, let's have a look at that. And the other kind of chord is this kind of chord. You know, that is in fact built from a series of major thirds. So it was very, very interesting to see that. Perhaps if we have time, I'll show you an example of a program made by Louis Bigot in EITAM. Unfortunately, the former program that was realized in Open Music is no more working. But we have another one, a little bit different. And if we have time at the end, I'll try to make you understand what's the purpose of it. So it allows us to show a representation in a specific representational space that comes with the music. And of course, it is very interesting. So this idea that music deals with needs in some way a specific space for its representation is not so new, and we must say that there were a lot of intents those last years about that. For example, I will show you some examples. All those examples are related to mathematics, you know. Here, this is the representation of three sound chords, and it tries to take into account all the possible symmetries. This is another one. This one is trying to make it in the way of a Möbius strip. I don't know if it's simpler to understand. And another one here from Gilles Barouin, a 3D projection with a model of planets. You know, so it was a metaphor that was used by several authors, this metaphor of planets. So it's spatial metaphor. But, of course, the problem, the evident problem of all that, all those representations are interesting, but, of course, what will be the more interesting in the course of an analysis? That's one of the questions. What tells you the specific space you have to use to make a representation that means something? In fact, this kind of representation dates back from the beginning of the 18th century, when musicians tried to understand how it was possible to make an equal temperament. This is the first Euler representation of a network of sounds, of network of notes, and it was dealing really with the idea that there was quints, you know, in this way, and thirds, minor thirds, in this way. He made a more clear diagram a little bit further in the late 18th century. But this kind of representation was nearly forgotten. It's interesting, this history of the representations, because they are invented, forgotten, because we don't see really what it means, what it's worth. Is it really useful? And sometimes it goes back. It goes back. For example, this representation was used also by Riemann at the end of the 19th century, and was discussed in the middle of the 20th century by Longuet-Higgins and also by Steedman. And they were trying, you know, this representation is exactly the one proposed by Euler. But this is a little bit different. The representation proposed by Steedman, it was in 1962. 1972, sorry. So 10 years after. So why preferring this to that? It's not so obvious. You can try to understand, but it's not so obvious. Another implementation of this idea was given with what is called now neo-Riemannian analysis by an American musicologist called Richard Cohn. And Richard Cohn tried to understand, and we'll see that it's in fact a very important point, both the chords and the relations in between the chords. So this is something yet a little bit different. And he saw that you could change from one chord to another one, only changing one note. And this is what is called parsimonious voice leading. So he had a perfect mathematical underground, saying that in fact with three basic vectorial transformation, you could represent all the transformations. So it's very interesting, and in the work of Kohn, there is also a very interesting thing that he said, okay, we have this idea of making a space with two vectors that are intervals, but we can choose any interval. And why choosing this kind of interval or not another kind of interval? Why choosing to represent in such a case? And he demonstrates that in fact this representation has a big, for his parsimonious idea, something very interesting, that is that in fact, you know, it's 3, 4, 5. It means that you have here a minor second, here a minor second, and then here it's 10, but you can read 2. It is a major second. So it's interesting because it's the only one to have this property. So this is something epistemologically interesting. It means that we have a broad possibility, a broad world of representations, but some of them have specific properties. Now, in fact, there is a continuous relation in between lots of this representation. For example, this is a square representation. You can have it hexagonal, and you can make transformation so to have the intervals seen in another way. For example, if we have, sorry, I want to my, up. Here it is. So it is very logical for Kohn to have x, y, I don't know in English, and then the sum. This is very logical, but you can also have it like that in an hexagonal way. For example, here a minor third, here a major third, and here the sum of both. You can have it this way or this way, and it is a quint. Okay, very fine. Then another proposal from Candace Brower. She says, well, this is nice. We can have it like that, but it would be very nice to have a projection of all the notes on a vertical axis so that we can have the chromatism as a vertical axis. The same, and not exactly the same, because it allows you to see something else. It is related, this idea of projection on a vertical axis, with a proposal that made James Taney in the beginning of the 1960s. And James Taney was dealing with just intonation. It was very important for composers. We'll see that a little bit further. American composers of the 60s. But Candace Brewer tells us something else, and this is very interesting, because she's saying, oh, okay, so I have a vertical axis, and then, let's say up, we go to the dominant, and down we go to the subdominant. And so up is tensing, and down is relaxing. It's very interesting because it reminds us of Mersmann, of this idea that we have a projection on an axis of tension and relaxation. Of course, it is an hypothesis. We have no proof of anything in that. But you see how the representation is beginning to try to meet with things that we need to understand within musical matter. That was the first point of this part. Second point of this part, the idea of topology. If we have spaces, we only need a distance to make a topology. That's the definition of topology. But what is distance in music? It's not clear. Of course, if you imagine cycles of intervals, you can define different sorts of distances. For example, here is the chromatic distance. C sharp is very close to do, to C. Sorry. This is on a minus second distance. But if you say the distance is a quint, well, it's F and G that are closer to do. And same thing with the third. So distances depend a little bit of what you understand as distances. So chromatic distance, it is very well known for the pianist, for example. It's a different touch of the piano, one beside the other. And of course, there is in music a kind of contradiction in between the contrapunctal distance and the harmonic distance. For example, here I showed this diagram is only the concordance of one note with the other. We can have it as a distance. It means that C sharp is very, very far from C. C sharp is very, very far from C. But C, at the distance of an octave, is very close from an harmonic point of view with C. So we have contradiction. We have two distances that are contradictory. And we would like to make a space where those distances will not be contradictory. Of course, it's impossible. It's impossible, but we can tend to it. For example, if we imagine that our chromatic line makes a spiral so that all the octaves goes close one to the other, well, it's okay, it works. You have the octave closed and you have C closed and C sharp closed. You can also do that with quint. And you can even do that 2 times, showing the third in between. And this is exactly what we've seen with the hexagonal representation. So, okay, we now understand something a little bit better. It means that our hexagonal representation can be related, this is Candace Brewer, with the piano, vertical projection, but also we have this continuous spiral that allows us to understand better what are those relations. Okay, so this makes the thing a little bit more complex. Here I've shown all the harmonics of C, and you see that most of those harmonics comes into the regular note of the piano, but not all of them. Some of them are completely out of the space. And of course this is very interesting because it kind of allows different kind of interpretation of the same representation. Let's see something else now. As we've seen with Köln, there are different ways of making this representational space. And this is also true because in fact it's completely arbitrary to say, okay, my spiral goes to the quinte or to the third or to the thing. So we can have different possibilities. And those different possibilities correspond to different way of understanding harmonic space. And this is very, very interesting. For example, here I represented the one that everybody uses nowadays, Do, C. This is a major chord, minor chord. Okay, but this one is also very interesting because I find Do. Where is it? It is here. This one shows you have a kind of major chord here, but it's in between Do and C and F. Okay, so what does it mean? And of course you can have this with A, and also with H. It means that in fact this idea of minor major chords and this idea that in some space there is a capacity of some chords leads to understand that in some systems you could have minor and major chords completely different than what we have to we are used to sing. Of course, in this case, it's the same, and it's perhaps why tonal music is so important, because it uses all the central parts of the representation. You know, this is minor chord, but it's just renversement, I don't know how to say that in English. The reverse chord. But this is very interesting, because, for example, this representation is, in fact, a very good representation for pentaphonic music. So, this is the kind of thing that we will be able to see in Luis Bigo's program, because we can make every representation possible. Let's have another example, perhaps it will be clearer. It's a very simple example. The beginning of Liszt, Grey Clouds. You know, it's very simple. It begins with a chord that will fit very well this representation. It will be compact in this representation. And then at the end, there is another chord that will be compact in this other representation. So in fact, it's very interesting because it tells us that the idea of compacity and the idea of harmonic system can be related, one with the other. I've even got a worse example, if I can say that. Oh, we can read it. Okay, but that doesn't matter. It's from Desert, from Edgar Varese. And it shows you that, in fact, the logic of Varese is about this kind of representation, with, in fact, the ninth taking the place of a king, to say it like that. But well, it's okay. So all those representation, of course, it's interesting because you can have the chords. This is the listing from Forte that is impossible for the students to learn. This is, you know, more vivid because it's like drawings, you know, and all the character of the chords, you can see them. It depends on the drawings they make. So if you learn a little bit how it works, very, very easily you have the possibility to understand what's happening in music that deals with something else than just the tonal system. So representational spaces can be very helpful, in fact, and they are related with very basic physical things. Here is a representation of the concordance in 2 dimensions, and the kind of chords that you can see that if in fact it's a system that can communicate with the reality of what is really harmony. You can also see that it's very simple to understand. 1 hour to explain tonal system with this representation. It has been used by pedagogues, for example, in Canada, in the end of the 20th century. It's very interesting to see that all those representations have different understanding. Here is the representation of the cycles of the chords, the third, you know, and it's very interesting to see that it fits with some also from some very well-known circular representation of the degrees, you know. Just that it has this kind of and if we go a little bit further, it can help us also to understand what's happening with minor tonalities and why it is so more complex and allows such different combinations than just okay. Well, it will take a little bit too many times to explain that. But just to say it very simply, in fact, when you have a representation, it's always interesting to know what the former way of thinking harmony and things like that was looking like in this new representation. And this is very epistemologic to understand that. So there is no difference, in fact, mathematically, within these representations and Tene's representation about just intonation. You know, just intonation is just slightly moving the position of the... And that's why the representation with the spiral is interesting, because you can understand with that in fact it doesn't move the system, but just moves a little bit the point. And for example, it can be very interesting to see the logic of Arabic makams with the hexagonal representation. Here you have some examples. It's another way of seeing the makams, because usually you see them in a diatonic way. It's the way, the historical way. But this way of seeing is very interesting because it gives some cues for something very important in Arabic word nowadays, that is harmonization of the makams. I had a Syrian student. Unfortunately, he went back to Syria, and I've got no news of him. But that worked on that, and it was very interesting because it could help to understand why things were working, harmonizing maqams, and things were not working. I also use that, you know, it's, well, this is to explain that in fact, if you see the deployment of harmonies, you have an area within the quints with 3/4 of tones, and here within the octave with semitones. This is also a problem of representation. When you have this kind of representation, you understand things in music differently. And this is the last point about that, because all these problems of representation has also some things to do with compositional problems nowadays about what is the theory we have about harmony within the microintervallic world. And I must admit, as a composer, that all those representations helped me to understand better this world and to be able to propose harmonic solutions where I have, of course, my ears, but the multiplicity of those words is such that in fact finding some solutions is somewhere more coherent. Here you see it's drawings I made for a microtonal piece for 2 guitars with using the division in sixths of a tone, and it was useful for me to have all those representations to be able to understand how to get into the harmony of this brand new world, because I had no accuracy from a former culture about it. So that's a point really important, because it shows you also that representing something helps changing your ideas about something. A new representation means new ideas, means new possibilities for the creation. It was very, very evident with sonogram representation. In the 20th century, it changed completely the way composers had the relation with the sound. So now we go to the last part of this. I will be very. I try to do it very rapidly, because all this has implication for musical instrument. In fact, this is a table where all the possibilities of music, because you know it's very simple to understand. This idea of spiral is exactly what happens with string instruments. It's a line, and you're getting back. For with quints, if it's a violin, with fourths, if it's with fifths, quints, it's fifths. Sorry, my English is not so precise. And of course, it is very interesting to see that everything, or nearly everything, have been tried, and if it was not in the course of the late history, it's in the course of modern history. For example, Harry Porch, he tries a lot of configurations, and all those configurations are related to a kind of representation of the distances within intervals. All Porch instruments are related to that, in fact. This is another example. It's an RPG, you know. It's another representation. Oh, I hope sorry, it's not working very easily. So it works like a dulcimer, and it has this this underlying representation. You know, the difference in between chords are very, very thin. It's a second. I show you another one. So this one is an array marimba, array bira. It's a marimba, in fact, kind of marimba, but with another implementation. So this one, it's the contrary of the arpeggio. It's with very broad intervals in between the different strings. Of course, there is a very well-known instrument already using hexagonal representation, and it's the accordion, of course. But we already have instruments using the theoretical representation. You know, it's something like that. Okay. So this is the way it is formalized. So you can make this an instrument. It means there is this is the idea here. There is a strong relation in between representation, instrument, and then in between instrument and musical system. Because we had 3 examples, very simple, but you can imagine that in fact you don't play the same music on all those instruments. It means that there is a relation of what is the most easy things to play, and what is the most idiomatic. That was the word I was looking for. Well, I don't. I think it's clear, and it's a very, very, very big theme now, especially with microinterval instruments, because it's quite complicated. There are a lot of proposition here. The tonal plexus. It is an instrument able to play a lot of specific microintervals, and you are obliged to imagine new instrument to play this new music, and with those new instruments are new representations. So my third point, representing time. So why representing time is something important? It's important yet for the harmony. Here is an example from Mahler. That's just, if we can have it. Well, it's the beginning of the Adagio of the 5th Symphony, but I don't think we have the sound. Just as a reminder. This is exactly the kind of music for which a new representation is useful, because in fact you are in between two worlds. And I'm thinking also about Prokofiev. I tried to make an example of what you shown last day, because it's exactly the kind of music we need, new ideas. So I made an analysis. You can do this kind of analysis in a piece of paper. Here, I just show you a little bit what it's about. You know, you have different representation of the chords, of course, and you can have it in one piece of paper. It's very simple. But what's interesting here is to understand the capacity not only for the chords themselves, but for the movement of the chords. And it is particularly interesting in this piece of Mahler because you see that in fact he's moving from a center point, okay, tonal center, but he's moving in all directions. And this is something new. Because usually, you know, in tonal music, the main direction for movement is vertical direction, because it's more efficient. Despite with romantic music, well, you begins to go laterally. And it's interesting to see that Mahler goes in all directions and within very little time. So this is related to time, but the main problem we have in music is a relation in between a concept we use, that is form. I can define form within a geometrical work. You know, this all has a form. It's very easy. I have the geometry. I can say the form. But what is form with music? What is temporal form? And this was one of my main topic. You know, I wrote two books about that. With some things you can read in English, some papers, dates back from the last century. And I want to propose a specific representation that a little bit looks like that. This is the way it's useful for polyphony. This is a representation, for me, of the melodic form of a fugue by Bach. If I show you like that, this thing, you say is crazy. It's not possible to have a drawing of musical form. So let's make an experiment. I hope I won't have problems. I do have problems. No, it's okay. That's the way the new Macs are working. I think everybody understood what's happening. So it's nothing else, in fact, than a paradigmatic analysis. Just that we can have it for polyphony, and we can have it. We can see a whole piece at a glance. When I first make those diagrams, it was something completely new. We never had this possibility to see a piece at a glance. And what was the meaning of what we were seeing? So the architecture here of the fugue is completely clear to me. I'm very used to this kind of diagrams. You need to a little bit to have some to be a little bit aware of what it is about. But and it's always the case with the representation. In fact, you need to understand the EKIS as a basic thing. So here I can read a lot of things about Bach's music. In fact, I can see that in fact it's a fugue from a certain kind of fugue. There is no stretto. It is a fugue where, in fact, the purpose is to have a distance each time bigger in between the coming back of the subject. Is you say in English? I think. Okay, and the theme. And in fact, you see also you see two things here. You see that the main material is exposed here, and then there are those divertimenti, very specific, that comes to be in fact the most important thing in the piece. And with what I call the discovery front, in this way here, and in this way there. I mean, with a curve that is different. Curving time and being able to see this curve is something very interesting, in fact. Okay, now, representing time. You've seen that to be able to understand the visual things, you needed something moving on it. So we were not able to represent time, really. It was a kind of convention. The position of something in the space is related to time. The thing, and it will be one of the last one I'll speak about. The thing I want to make you understand here is the thinking of a great French physicist that is called Henri Poincaré. Henri Poincaré is probably one of the physicists that goes very, very far in the understanding of time. This text is very interesting. The order in which we rank conscious phenomena has no arbitrary. It is imposed on us, and we can not do anything to change it. I have just one comment to add. If an aggregate of sensations becomes a memory that can be classified in time, it must have ceased to be in actual time. We must have lost the feeling of its infinite complexity, otherwise it would have remained present. It must have, so to speak, crystallized around the center of association of ideas, which will be a kind of label. Only when they have lost all life we can classify our memories in time, as a botanist arranges in his herbarium of dried flowers. But these labels can only be finite in number. If it was so, psychological time would be discontinuous. Where does this feeling that between two instants or other moments come from? We classify our memories in time, but we know that they are blanks. How could that be if time was not a pre-existent form in our mind? How would we know that there are empty boxes if these boxes were known only by their content? This is very near an Augustinus, I think, of Hippon, thinking about time. But it is very interesting because there Poincaré points something very important for us musicologists. It is what philosophers call the problem of synthesis of time. Synthesis of time, what it is about? It is that in fact our sensation is in connection with real time. Let's call it real time. But our cognition does something else. And there is not a discrepancy, but there is an adaptation, a necessary adaptation in between the sensation and the cognitive layers. So this is, to my opinion, the main problem with time. And Poincaré, he said a lot of things about time that are lovely. For example, I love this quotation. Times must be defined so that the equation of mechanics are as simple as possible. As simple as possible. It's the simplicity of the equations that defines the time. He has no, as a physicist, he has no other definition. It's very interesting to think of that. It means this means that our definitions depend on our representations. This is what it means. And he invented a very important representation for dynamic systems. That is here, problème des trois corps et les équations de la dynamique. In fact, this is the first occurrence. We are in 1890 of what we'll call the phase space, espace des phases. Phase space, in fact, it allows you to understand that a movement can be represented either, here you can imagine a pendulum, you can have it, the movement of this pendulum as a trace here, it's very common, but you also can have it like that, with two axes, one the position and the other one the celerity. And this changes everything. We musicians are very, 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 very used to that because we have this duality in times. We have notes, but we also have intervals. We know that a melody is notes, add one to the other, but also intervals add to it. And we sing, both sing at the same time. Pierre Barbeau used this representation in a kind of statistic way in his first writing about algorithmism in music. It means that here you have the position, here you have the transitions, and you can make analysis with that. The first one to do that was Michel Philippot, as far as I know. Perhaps there is somebody before him. But he analyzed Beethoven with that, showing the note and the intervals used by Beethoven on a statistical basis. And he was very conscious, Philippot, that was the signature of a style. The way you articulate the note and the transitions, position and transition, give you an image of the style. It means that some transitions are never used, and other transitions are very, very often used. And this says something about the style of an author. So there we have a close relationship in between what is space, what is moving into that space, and all the relation in between both tells us something about the kind of music. For example, I have a little example of well-known analytical example, the Geisler league used by Chouvel. And this is a drawing where you can see the way modality is working. So it begins like that. And so on. This is a very simple representation, but it can allow you to see many things. And this way of seeing things, you can use it at different levels. You remember Langner, this idea of a scale of level of time. Well, you can do that exactly the same. For example, I did this with Mozart Rondo, and you have here at different levels, every part of the score is following another part. And what's interesting here is that you have two representations. One is with rules. Let's say it's grammar. And one is a kind of statistical drawing table here with positions and transitions. And it's the same. It's the same information. Very important, very interesting this. It means that at different levels, you can have at the same time a representation with phase space and a representation as grammar. And in fact, it means the same. Well, I think we don't have really time to see that. Just showing you a little bit what it's about. Here is okay, so it's very simple rondo, everybody knows it. And this is a form in exactly the same way we've seen it with Bach. Of course, you can show a structure at different levels of this form. No structure means getting with bigger and bigger blocks. And you can have all those representations at the lower level and the higher level. This means that this is a kind of what I call a structure Markov. This is a Russian scientist. Chain. Markov chains are usually on one level, but in fact, in music, we need several levels to understand what's happening. So there is things that is very interesting. For example, here, the paradigm variation depends on context. And it's very easy to understand why it is like that. And also, there is always a balance in between simplifying rules and charging, making static memory bigger. So all this is very interesting and dealing with what I call cognitive musicology. What is called cognitive musicology. Now, another representation of time is this one. This is the very first drawing of a sound by Edward Léon Scott de Mandreville. It was in 1860. And we are all nowadays very used to that because all the programs we have in our computers know how to do that. They know how to do a piano roll, and they know how to do a waveform. In fact, we can do exactly the same with sound than we did with specific musical objects. We can see position and transition, but nobody's take care of it. So I wrote an article with Jean Bresson and Carlos Agon in the EITAM, trying to show a little bit about that. For example, if we have two notes, one after the other, I need to oh, mais là, j'ai quasiment fini. De 5 minutes, c'est bon? Ah bon, sinon, ouais. Just one word about that. Yes, my English is a little bit slow. I'm sorry about that. In fact, you can also represent the way in a specific bandwidth frequencies are changing. It means here, for example, frequency, the energy becomes important. And of course, this changes completely the way of seeing things. For example, instead of having a flat, for example, note with an organ, you can see the transition much better and see the differences in between the different intervals. So different intervals leads to different energetical transition. And it's very nice result, and it leads also to understand what is the melody, a true vocal melody and vocal style. You can try to make drawings according to that, and understand that in fact what you thought to be here it is. This should be the sonogram frequency time, and this should be the phase space. In fact, the real phenomenon is in between, and what you have for you thought it was a definitive representation is in fact a specific projection of more intense representation. This is also something very important to understand, that in fact we never finish with this word of representation, because we see only a part of it. Perhaps we can conclude with that. It's yet lots of things, and perhaps you have some questions. I hope I was clear. I'm very sorry about my English. I did my best, but it's not so good.